All right, so last lesson we introduced systems of equations we solved with graphing. We're going to look at a couple other methods in this lesson. So one of those is substitution, one of those is elimination. These are both algebraic methods. Substitution, first off, good method if you can easily isolate one of the variables. I can get y all by itself or x all by itself and then substitute things in the other equation. I'll show you an example of that. Elimination, honestly, is kind of the go-to, probably the favorite one overall, because you can use it for any of them pretty easily, okay? And I'll show you that as well. Now, graphing, especially with a tool like Desmos.com, of course, is extremely easy just to graph those. So I would encourage you to certainly use that as a good way to check yourself, but I'd like you to understand these algebraic methods, because as you progress in math, you get to higher math classes, the problems get a little hairier, the solutions aren't as clean, and so you'll want to have as many tools available as you can. So let's go look at an example of substitution. So solve the system. Now it doesn't come out and say substitution, but I want to go ahead and use substitution on this one. And as you go through the practice quiz today, it'll say solve by substitution or solve by elimination. I really don't care how you solve each one, because some of you may look at it and say, well gosh, elimination looks way better than substitution in this one, or substitution looks better than elimination. So, you know, whichever makes the most sense to you in a given one, I would say go ahead and use. So let's solve this one. Now here's what I'm talking about. Substitution, x and y, either one of these has a 1 in front. So I could isolate either one very easily. So like in this second equation, maybe I bring the x over, so y equals negative x minus 12. I just subtracted x from both sides, right? Well, what that allows me to do, if y is the equivalent of all this, I can then go substitute that in for my y value in my first equation. So let's do that. So 2x minus 3 times negative x minus 12 equals 6. Notice what I did. Now I've only got x's, and I can solve for x. So 2x, let's go ahead and multiply that through. So plus 3x plus 36 equals 6. Now I've got a little algebra equation, right? So 5x, let's subtract that 36 over there, equals negative 30, and divide. Hey, looks like x is negative 6. Now we're not done. I need to figure out what y is, don't I? So now I can go plug this in either equation. I go to this second one because it's simpler. And so negative 6 plus y equals negative 12. Let's add that 6 over. So y equals negative 6 as well. So in this case, it looks like my solution is negative 6, 6. And if we check it real quick, negative 6 minus 6, negative 12. Hey, that works. 2 times negative 6, negative 12 plus 18 equals 6. Hey, that works. And there we go. And again, graphing like in Desmos, you could check yourself really easy, especially if you're doing a post-test, doing a final exam, something like that. So that's the basic principle behind substitution. Let's look at elimination. Solve by elimination. So if I look at something and I say, gosh, those are really similar, if I just added these together, my y's would disappear. So if you see something really obvious like that, or maybe you just need to multiply a negative through one equation and then add the two equations, either your x or y would go away. Elimination is a very, very clean method. It also is a good method for, you know, if there's nothing real obvious that lines up, you can multiply something through one or both equations to make something match. I think the ones I give you in the lesson today are really pretty straightforward. But so in this case, my signs are already opposite, so let's just add these two equations together. So 2x plus 3x is 5x. 5y minus 5y goes away. Negative 24 plus 14 is negative 10. Divide. Hey, looks like x is negative 2. Look how quick I just solved x is negative 2. Now I still need to figure out what y is, don't I? So we're going to go substitute back in. Doesn't matter which equation. I'll go ahead and choose this second one. And so 3 times negative 2, that's negative 6, minus 5y equals 14. And now to solve the equation. So let's add that 6 over. So negative 5y equals 20. Let's divide that negative 5 over. Looks like y is negative 4. So -2, -4 looks like the solution. Of course, you could go check yourself pretty easily and see. So substitution, isolate a variable, substitute stuff in. Elimination, see if you can combine the equations in such a way that you'll eliminate a variable. Very similar from there though. Let's go look at another one. Now this one, elimination as well. Notice there's nothing I can add directly that's going to wipe something out. And you can choose a lot of times, depending on the coefficients, which one you want to get rid of. In this case, and I'm doing this problem to illustrate something, let's multiply 3 through the bottom equation, okay? I'm just going to rewrite the top equation over here. Now let's multiply 3 through the bottom, and it gives me -9x plus 3y equals -3. You can maybe see what's going to happen here. Well, let's combine these equations. 0, 0, 0. I get 0 equals 0. Well, what does that mean? 0 equals 0. That means that these are the same equation. Okay, so this is a dependent system, and it has infinite solutions. All right. So if you get 0 equals 0, that's true. Infinite solutions, that's a dependent system. Now, what if I did this and I ended up, all my variables went away and I got something like, oh, 0 equals 7. Hey, that's not true. What would that tell you? That tells you that there is no solution. Okay, that's an inconsistent system. So just a couple things I want you to look for as you go through the lesson. All right, again, I hope you're taking notes. I hope you're working problems out as you go through these lessons and these practice quizzes that'll really help you really understand and kind of absorb some of these ideas.